All right, example 4 says we are given a function. So we are told that this is a function. We don't have to worry about that. But again, if you were going to check, remember, a function means that each x gets its own y value. So each x occurs one time. So -3, -2, 0, 1, 3. So all the x's occur once. It's a function. Is it a linear function? Linear functions are lines, meaning the slope never changes. So what you have to do here is you have to find the slope between each pair of points. So I'm going to have to do this 4 times. So sorry about that. I know it's a little laborious. So here we go. I'm going to find the slope between these 2 points. So slope is change in y over change in x. So my change in my y's is -10 minus -7, -10 minus -7 over -3 minus -2. -10 minus -7, that's -10 plus 7 or -3. And then -3 minus -2, that's -3 plus 2 or -1. So the slope is 3. So as long as all of my slopes continue to work out to be 3, I have what looks like a linear function. If any of these are different, we can stop because we do not have a linear function. So the next pair of points, I'm going to do the difference between the y's, the difference between the x's. So -7 minus -1, that's the y's, and then -2 minus 0. -7 minus -1, that is -6. That's -7 plus 1, so -6. -2 minus 0 is -2. -6 divided by -2 is 3. So far, so good. The slope has not changed. Okay, that's what makes something a line. The rate of change stays the same. Let's do it again. So the next pair of points, I've got -1 minus 2. So this isn't a -2 this time. It's -1 minus 2. And then I have 0 minus 1. So -1 minus 2 is -3. 0 minus 1 is -1. I've got a slope of 3. So again, the slope has not changed. One more time, just to be certain. So the last pair of points, 2 minus 8 is the change in the y. 1 minus 3, whoops, that's a 1. 1 minus 3. So 2 minus 8 is -6. 1 minus 3 is -2. And for the 4th time, we got a slope of 3. So every indication is that this represents a linear function because the slope has not changed.